Hello everyone, my name is Rina Hasuike from Yamaguchi University in Japan. Today I'd like to present investigation of galvanic corrosion properties on stainless mild steel welding joint and atmospheric environment. It is really initial stage and in this research, so I'm happy to get some comments and questions from you. Okay, let's start from the introductions. My focusing on the bridges. Those pictures show the beautiful bridges in Yamaguchi Prefecture. So if you have come to Japan, please visit us and enjoy those bridges as well. So, and see, when considered the materials of bridge superstructures, in Japan, 38% of all of the bridges is made by steels. And about deterioration of steel bridges, the corrosion and fatigue is two main reasons. And about the my focus is on corrosion, and those pictures shows the examples of mild steel and with paint and weathering the steel corrosion deteriorations. So in order to prevent such corrosion deteriorations, using high corrosion resistant materials such as stainless steel is considered. However, the material cost is about 3 to 4 times of mild steel or weathering steel, so it is difficult to use entire bridges. So the combining SM or SMA and stainless steel is suggested to reduce the cost and obtain the corrosion resistance. So where should we use the stainless steel? When thinking about the existing steels, the center of the garden looks good. However, in the end of the garden, it's sometimes really crowded. So I suggest to use stainless steel for only the end of the garden. And when combining SMA and stainless steel, the galvanic corrosion the occurring is concerned. This figure shows the little bit images of the initial stage of corrosions. When you use the mild steel and mild steel, has same electrical potential, so the anode and cathode is occurring everywhere in the steels. However, when you put with stainless steel, such as the high electrical potential materials, the anode and cathode is fixed, so only the anode side is accelerated, because maybe you know these galvanic corrosions. So far, some researches of galvanic corrosion is conducted in civil engineering. It is under the seawater or any solutions, but under the atmospheric corrosion, such as the exposed bridges, is not a lot. So I try to do that. And this is my purpose of this research, to clarify the galvanic corrosion properties of stainless steel and mild steel welding joints under an atmospheric environment, and in the future to propose the painting area for suppressing the galvanic corrosion. And in order to achieve these goals, the method is the first corrosion acceleration test, second measuring glass thickness, and third measuring electrical potential. So let's start from the corrosion acceleration test. This figure shows the cycle, first time supplying the 500 micrometer solutions via pipette, then repeating the wet environment and dry environment. And about the solutions, I choose the 0.1% NaCl solution and tap water in order to compare the effect of chloride. Then this one is short specimens. I choose the two types of weld finishing as well as blinding. In order to compare the differences, when under the wet environment and become drying in asphalt specimens, it may be that the water is keeping much more than blinding specimens, so I'd like to know the differences in them. And also I choose two types of different materials, the SAS304 and SAS821L. And also as the base, the SMSM combination is conducted as well. And this picture shows the specimen's appearance after 1 to 4 cycles. As shown here, of course, the tap water, 0.% NaCl specimen is more chloride than the tap water. And when compared with SMSM and SAS-SM, for this line, then it looks more clouded than with this one or more this one. Yeah. So and next slide, let's make sure the differences of them. By measuring the last thickness, first they are measuring 10 points in each area, the area X and area Y, by plotting thickness scales as shown in the light figures, and calculating the average taken by excluding the top and bottom tails of the data. And about the areas, why I choose this one is to consider about the distance from the SAS and SM, because distance in here, distance meaning for the cyclic, for the electrical, so it means the resistance of the electrical. So I'd like to know the differences of them. And this one shows the measurement result after one for both cycles of the asphalt specimens and NSL and tap water. As shown in here, with the NSL subline, it's really accelerated some upper tap waters. And when considered about the asphalt and grinding, for both of them, it's no big differences in each the welding finish types. And also when compare the in left side, the SAS 304 and SAS 81, and right side as well, it's not a big differences as well. So from this one, I can say that there is no big difference in each weld finishing types and materials. The next, I try to find the area differences. For left side, it is almost 1.6 times, and right in the grinding specimens, it's more 2.0 times. So it is opposite result what I expected. The in grinding specimen is very flat, but it is more accelerated in area Y to X. So now I'm trying to figure out that. And from this one, the corrosion is accelerated in the area of close to the welding, which means the short distance is more accelerated. And this one shows the 216 cycles, which means more accelerated one. As shown the light figures, it is of course more accelerated before that, but the more correlated, the smaller differences between SAS-SM and SM-SM. It might be the SM-SM also correlated more and more. Right now it's campaign. And at the last of that, I'm sharing the measuring experiment, electrical potential result. Then it is the first conducting corrosion test as shown below, and cutting the specimen into the left side, as in left figures, and each part is illustrated and covered with epoxy, and cut the surface and measuring the electrical potential as shown in the light figures. And these figures show the measurement result after 72 cycles. When you and the dash line is the initial, and the plate line is the after corroded result. For the SAS 304 result, when we check this area, the electrical potential is really lower than the initial for here. And also when checking about this SM, it is a little bit higher than the initial, which means there is occurring the galvanic corrosion because the electron is moving from here to here, I guess. But when we check the A21L specimens, it is totally different looks. So now I don't have clearly reasons for that why. But in here it's a little bit higher than initial. But in SM is also same, it's really higher than that. So it can say the electron is moving, but I don't know right now how to move that. So I will consider about that. And for now, this for SAS 304, anode polarization is more accelerated close to the welding. And when more accelerated, in 216 cycles, as shown in here, the path side is more less the potential in the SAS 304. SAS 812, it's still a little bit higher than initial, but compared to this one, it's a little bit lower. So it can be the state if there is the occurring the exchanging the electron. So, and right now this is 304 occurring anode polarization area is split to here, I guess. And about this SAS 821L specimens, now I try to figure out what happens by the analyzing the last composition and structures. Okay. In conclusion, the galvanic corrosion was occurring under an atmospheric environment supplying 0.1 NaCl solutions. And from the last sequence results, there were no big differences in corrosion rate in materials. Now about the SM corrosion rate, there were no big differences between the two types of weld finishing. And at grinding specimen, the acceleration rate at the area close to welding is higher than that of as-weld specimens. And from the rust thickness and the electrical potential, the galvanic corrosion may occur up close to the welding in the initial stage, especially in SAS 304 specimen, and therefore painting in a range of more than 10 millimeters from the welding, it means close to the welding might suppress the galvanic corrosions. And for the last one, now I'm conducting the test with painting. So I hope I will share with you in next video or next time. So this is the end of my presentation. Thank you for your kind attention. Thank you.
Very interesting observation.
Thank you.
Just say, like from the observed corrosion, is that only because of the difference in the material helping, or that maybe also because of the strength?
Yeah.
Application we generate the higher stress. And stress might also reduce corrosion.
Yeah. You mean stress?
Yeah.
I didn't check about the stress of the strength of the materials. You mean? Sorry.
Yeah, we weld two components together.
Yes.
We have a stress competition.
Yeah. Yes, exactly. Yeah, I'm sorry, I didn't mention about the in my presentation, but yes, of course, there is heat affected area, so it may changing the strength and yeah, more weaker than other parts. So maybe it can be affected for the corrosions. Yeah. Thank you.